All right, let's get started. Any questions about anything so far? Anything we covered? We're good? Okay, so we are now getting into week 6 with you, and week 6 talks about functions. So what I'm going to do today is I'm going to show you some functions. So I have already written some of this stuff for the previous class, so that I don't have to type all of it again. I'll kind of reuse it, if you don't mind. Okay. So first of all, suppose that I have these 5 lines of code, right? It just could be whatever you want. It's something that you did in your program, and you basically wrote five or whatever, any number of lines of code, and then later on at some point in your program you're trying to use the same exact 5 lines of code again. Okay, could be 5 lines, could be 5,000 lines, could be lots of lines of code, and what you're trying to do is you're trying to recycle and reuse your code somehow. So how are you going to do that? Well, you're going to define a function. And in that function, you're going to put these lines of code that you're trying to reuse, and then every time you try to use them, you're going to call that function. So the way you do that is, what I'm going to do is first, this is before my main, right? So first of all, the main is the function where the program starts, right? The main is the function where your program starts, right? Any program, any C++ program that you want to be able to run cannot run without the main function. If you don't have the main function, it will give you an error message telling you that it needs the main function. So, what we're going to do is, first, on top of my main, right, I have some other functions written here. I'm not going to erase them yet, right, so that they're coming. So, but before my main, so this is my main, I'm going to write void, I'm going to say stars, and then I'm going to put parentheses and semicolon, okay? And this right here is called the function prototype, right? So I'm basically I'm telling my program, just like I would declare a variable, like I would say int d or whatever, I'm telling it there's going to be some kind of a function with the name stars, and then functions they always have these parentheses in them. Okay, so how do you know something is a function? It has parentheses. Okay, so this is my function prototype, which is basically the statement where you tell the program, hey, there's going to be this function called stars, and it's not going to return any value. That's what the meaning of void is, right? So the void is the return type of my function, and void means that it does not return anything. Okay, the function name is stars, and the parameters of that functions are none. The parameters are the variables that we are going to put in between the parentheses, if we want to put variables in there. Okay. So the function stars does not have any parameters. The function stars does not return anything. That's why it is void. Okay. Then the next thing, what I'm going to do is I am going to comment. So first of all, let me run this program so that you can see the. Now what are you complaining about? Main. And main. Show num int reference. Okay, 1 second. Show num int. Let me take this out too. And run the program again. And here you go. So these lines of code right here, these 10 lines of stars are shown right here on the bottom. What I'm going to do now is I'm going to take these out. I'm going to comment these 10 lines of code now, and I'm going to call my function. Okay, so this is right here, I'm calling the function. Okay, So this is my function call. You put the function name, you put the parentheses, you put the semicolon. What happens when you call a function is, as soon as you call the function stars, the program jumps to the function definition and executes everything between the curly brackets of the function. What is my function definition for stars? Well, I don't have it yet. So I'm going to go in there, I'm going to write that thing. So I'm going to copy my function prototype. I'm going to go after my main. So this is where my main ends. I'm going to collapse the main so that we don't get distracted, right? And inside my function stars, what I'm going to do is I'm just going to put those lines of code that I'm trying to repeat. I'm going to copy this, right? I'm going to paste this in here. And so what's going to happen now is as soon as I call my function here, I'm going to jump down to my function definition, which is right here, line 97, and I'm going to execute everything that's inside of the curly brackets of the function. As soon as I'm done, as soon as we get all the way to the end of the function, we're going to go back to where it was called, and then my program will resume working its way down. Okay? It's going to get to another function call. As soon as I get to the function call of stars at line 54, I'm going to jump down to my function definition, and I'm going to execute everything that's inside of it again. So the effect of calling the functions 2 times, just doing these 2 easy calls, is going to be the same as if I was to execute these 10 lines of code. Okay, so that's the purpose of functions. If I run this, there you go, same thing. Okay, so the purpose of functions is to recycle and reuse your code multiple times. Okay, any questions so far?
So wait, all you have to do is put the stars parentheses and then run the whole thing wherever you put it in the code?
Yes. So the first thing I have to do is I have to create a prototype which tells the program there's going to be a function called stars. Then I have to I have to write my definition, which is tell it what to do when I call the function, and it's going to show these stars. And then anytime I call the function like so and like so, so the first time I call the function, it will show 5 stars. The second time I call the function, it will execute whatever's inside of the definition and show the next 5 stars. Okay? Any other questions? Okay. So that's the important terminology here that you need to know is what is a function prototype, right? Prototype. What is a function call? And what is a function definition? So this is your function definition. Okay? So that's the first one. So far what you've seen is a function which does not have any parameters and it does not return anything. Okay? But you can have a function which returns a value. So the next example that I have in here is now what I'm going to do is I'm going to have a function which is called return 1. Okay, so that's the name of my function. The name of the function is return 1. Again, this is my function prototype, right? Int is the return type of my function, which means the value that is going to be coming back from that function is going to be an integer. Okay, and the parameters are still none because we don't have anything in between the parentheses. If I had some kind of a variable like int num, then my parameter will be num, but I'm doing that next. Next is going to be that example. Okay, so I'm telling it, okay, in the program there's going to be a function called return 1. What is return 1 going to do? Well, I haven't defined what it will do yet, so I'm going to copy my prototype. I'm going to go after my main. I'm going to paste it, remove the semicolons, put curly brackets, and I'm just going to do return 1, just like that. Okay? So next, what I'm going to do is show you how to call a function that returns a value. Okay? So, right. Yes?
When you declare the prototypes, those are all on top of the variables you need?
No. The variables, you're not going to have any variables where the prototypes are, even though I show you how there's a variable here. I'll explain that in a second. Do not, the prototypes, the function prototypes are going to be before your main. So this is my main. Before the main, on top of it, is where I'm going to create my prototypes. Okay, and then after the main is where I'm going to have my function definitions. Okay, that's the order of things, and I'll explain to you in a second why that's important, why you want to have that order. Okay, so again, on top of the main, before my main, I have a prototype called return1 with a semicolon. Underneath the main, I have my function definition, right? This is another function definition. I'm going to put it right here underneath this label. Okay, so then what are we going to do with my function call? So this right here, let's start one line at a time. The first thing that I'm going to do is I'm just going to call my function right here, return1, right? It's supposed to return a 1. How is that going to work? As soon as I call the function, right? As soon as I call return1, we're going to execute everything within the curly brackets of return1, right? And what is in the return brackets of return1? There's a return right here. Okay, and what is the purpose of this return? Well, as soon as we hit return or reach return1, the program will go back to where it was called. Right? So where am I calling return1? I'm calling it right here. Okay, so as soon as I call it, I go to my definition, I see a return1, and then I get this value 1, and I bring back the 1 right where the function was called. So I'm literally bringing a 1 right in there, just like that. Okay? So we'll go back to where it was called and return the value 1 where the function was called, right? And one important thing to mention here is that the function exits as soon as we reach a return statement. Okay? So now let me run this thing and you tell me why you're not seeing a 1 in there. I'm calling the function, it brings back a 1, but you don't see it. Why is that? If I had a number 1 here, is that going to be seen? Are you going to be able to see this? No, right? You need to see out. Okay, so in order for me to be able to see the value that this function is returning, right? That's why this thing here is not going to return anything. It shows nothing. But if I call it from inside of a cout, right? I'm calling it right here. This is my function call. As soon as I do the function call, we go to the function definition, we get the 1, we bring it back, and we have a 1 right here. And then you're going to get to see the 1. Okay, so I'm going to call this again, run it, and there's your 1. Okay, another way to call a function that returns a value is to do this. I'm going to say is some value, like return value, is equal to that function call. What's going to happen in this case? I call the function, I go to my definition, I grab the 1. As soon as I hit the return, I bring it back right here. Okay, so now my return value is equal to 1, and then I can show you the 1. Okay, so if I do this and I run the program, now you're going to get to see 2 1s. Any questions? Okay, so you return the value to where the function was called, right? You bring back the value 1 here, you bring back the value 1 here, you bring back the value 1 here. That's why we didn't get to see this first one, because it wasn't inside of a cout. Okay, so the moral of the story is if you're going to be calling a function that returns a value, either make some variable equal to it, or maybe call it from inside of a cout. You can also call it from inside of an if, different ways, right? You can call functions from other functions. Okay, those kinds of things. Make sense? We're good? Okay. So far now that now you know two different kinds of functions. You know a function that does not return anything and shows something, and then you have another function which returns something. All right? So the first one was this one here, shows some stuff using a cout. This one just returns something. And there's a difference between how you call each of them. If the function is going to show something, if it's going to have some couts, you can just call the function like so. There's nothing, nothing else to do, nothing else that you need to do. But if the function is going to be returning a value, you can't just call it like this and expect for it to do something. Well, it will do what it's supposed to do, but you're not going to get to see the result. So you have to either call it from a cout, or you make some variable equal to that function call, that kind of things. Okay? So the next thing is, now let's look at a function which is going to have something in between the parentheses. Okay? So, third type of a function is, again, I'm going to go back to a function which does not return any value, so it's a void. Okay? The name of my function is shownum. And again, this is my function prototype. And void indicates that the function is not going to return anything, just like that first one didn't return anything. This time, I have a variable in between my parentheses. So I have int num in here, right? So what is int num? Int num is your parameter. Okay, the parameter are the variables that we put in between the parentheses of a function. Okay? This variable is going to receive a value that we're going to send into the function. Okay? So the parameter will receive a value that we pass into the function. Okay? So passing a value into the function is going to be done with this parameter. So how am I going to call this one? Well, I'm going to go back to towards the bottom and look at this one here, calling a function that has a parameter. Let me take out these three. Whoops. All right. Okay. So I'm calling a function that has a parameter, right? The function has a parameter. That means that we're going to have to put some kind of a value in between the parentheses. These other ones did not have parameters, and that's why I could just put the parentheses with nothing in between them. Okay, let me just try to see what happens if I put a number in here. All right, I'm just going to go put the number 10, just like that. And I'm going to try to run the program. And now what is it saying? No matching function to call to stars, right? What is it saying? Candidate function not viable. Requires 0 arguments, but 1 was provided. Okay? So again, that's why you got to know your terminology and know what an argument means. What is the argument? The argument is the value that you're putting in between the parentheses. Okay? The value that we pass into the function. Okay? So what's going to happen is, as soon as you do show num and then you put the value 10 in there, you're going to go to your function definition, which I haven't written yet. So let me write it.
So wait, real quick, the only reason that you can add a parameter to stars is because it's a void function? Or?
No. The reason I did not, so why I could not add an argument. So if I wanted to add an argument here, that means I have to redefine my prototype. I have to say int num here.
Okay.
So that it knows that it's taking in some kind of an integer or some kind of a number. Okay, so that's the reason why I cannot put a number in here, not because it's void. Okay, so that's now going to this one here. So calling a function that has a parameter. So if you have a function with a parameter, a single parameter, you have to send an argument. All right. So as soon as I do this, show num, let me copy it. Let me copy my prototype because I haven't written the definition yet. So I'm going to go in there, take out the semicolon, throw the curly brackets, and just do cout num equals num and del. And doesn't know what num is, so it's num1. Okay? So, what's going to happen? I call my function, I jump to my function definition. As soon as I call the function, this value here is going to become equal to 10. Okay, so this variable becomes equal to 10. Then I'm going to show you that num1 is equal to 10. Okay, so let's have a look at this. And there you go, right there at the bottom, num1 is equal to 10. Okay, I can call it with different values. Right? Here I'm going to call show num with 1,000. Right? So again, what's going to happen is as soon as I call this thing, the value of 1,000, num1 becomes equal to 1,000, and then I'm going to show that num1 is equal to 1,000. So I run this thing again, and there you go, 1,000. Okay? Now, you don't have to put a variable in there. I mean, you don't have to put a value in there. You could use a variable. Okay? So I'm going to do this. Okay? So this time I'm saying a is some variable which is equal to 100, and then show num parentheses a. So now a is my argument. But what we're doing is we're not passing the variable itself, we're passing the value of the variable. Okay? So in other words, if I did a or I did 100, same thing. Okay, that's exactly what's happening. I'm sending over the value of 100. As soon as I call the function here, right, it's basically the same as doing this right here, right? So whether I do this or I do this, it's going to be the same exact result. So if I run my program, you're going to see num1 100 two times. Any questions? We're still good? Positive? 80%. Okay. Any questions? Okay, well let's play around with this some more so that you get some experience. Okay, so these are basically these are the three basic kinds of functions that we could have. Okay, this that we're sending the value of a is the argument, brings me to something else. So what I'm going to do in here now is, let's see what example I had for the other one, so I can recycle it. Pass by value. Yeah, there you go. Okay. So now what I'm going to do is I'm going to define another function so that I can illustrate something here that, since we're passing a variable passing by value. So what I'm doing here is, this is pass by value. So all I'm doing is I'm passing the value of the variable into the function, right? So in here what I'm going to do is I'm going to create a function called pass by value, and just like usual I'm going to grab this thing, I'm going to throw it all the way to the top, right? I'm going to create my own prototype, right? Semicolon prototype, if I can spell it. Okay, so that's my prototype, and then inside that function what I do is, notice I say int b something. This is my parameter variable. Okay, and then in here what I'm doing is I'm saying b is equal to 0, and then I'm going to show you okay, here's what I'm going to do. So I'm going to say int b here, and I'm going to make b is equal to 99. Okay, that's the value of b. What I'm going to do is I'm going to show you the value of b so you can convince yourself that this is b. It's like I'm doing a magic trick. Now you see it, now you don't. Okay, then you do pass by value, and then I'm going to do a b in there, and then I'm going to do another cout, b is equal to b again, and L. Okay, so let's examine what happens. I am declaring a variable b here, right? I'm making it equal to 99. When I do a cout b, what do you think it's going to show me? 99. Better show me 99. Then I call the function, and I do a pass by value of b. So I pass the value of b, which is the 99, into the function, right? And then in the function I have a variable called b, just like this other one here, right? That they're both the same name, okay? And then in the function I say, okay, well b is equal to 0. Okay? And then what I'm going to do is, then as soon as the function is, basically that's all there is in this function, right? Nothing else. I don't have a C out, nothing else, right? So as soon as we're done with this function, we go back to where the function was called right after it, and then I do another C out. Now tell me, what is B going to be equal to here? 0. Okay, because I changed it, right? It makes sense. Let's see what it is actually. It's still 99. Okay? So why is that? Okay, well, because we're passing the value of B. We're not passing the actual variable B. Okay, and let me just give you an example. So what I'm going to do here is I'm going to show you cout memory address of B is, or let's make it equal to B ampersand B, and L. Okay? And then what I'm going to do is I'm going to do another call right here. Another cout. I'm going to say memory address of B and pass by value is ampersand B here, right? And then I'm going to run the program and I'm going to look at these two different, so this is memory address of B in main, right? Is going to be this, and then memory address of B is here. So let's run it. This is the memory address of the one in the main. So this one is this. And this is the memory address of the one in the function, which is this. Can you see that they're different? Let me put them right underneath each other. They're different memory addresses, right? They're close. They're not the same though. Okay, so what happens is, let me do that little Excel thing that I do. So let's say you have in main A, and then you're going to have in pass by value B. It's not A, B. Okay? So I have two variables. One is in the main, B in the main. Another one is B in, maybe I should put it in the beginning. There you go, B in main. And this one is B in pass by value. Okay, they're both B's. Okay, the value, the memory. So I'll do this. Insert. So this is a variable name. This is going to be location information stored in memory. That's a long one. And then in here I'm going to say memory address. Okay, and we already saw that the memory address of the one in the main, right? The memory address of the one in the main was this number there, right? And the memory address of the one in the pass by value was this other number there, right? They're two different places in memory. Okay? In main, initially I say B is equal to 99, right? So I put the value of 99 stored somewhere in memory. That's what's in memory, right? In the memory location 0x7FFFPF4968D4, there's the value 99. The way we refer to this memory, this information that is stored in memory is by its name, B, right? Just like if you have an IP address on the internet of google.com, you're not going to type 19 whatever dot something else. You're not going to be typing, what is that, 4 times 3, 12 sets of, 12 digits to get to google.com. You just type google.com and it figures out to send you to that IP address. Similarly, we have some kind of a variable name, B, which refers to some place in memory. So instead of me saying, okay, go to this place in memory, which is some obscure number that might change every time, I just say B, and then B refers to the same thing. Okay? So if I go to, if this is the value of B in main, right? This is the place, this is what it's stored. So then we go and we do pass by value B, we call it, right? We go into my B here, and now I have another B, which has this memory address, and in that place in memory, now I put a 0, like right here. But putting a 0 here does not change this number. Okay? And that's why this number stays the same. They're two different separate places in memory. One has nothing to do with the other one. Even though they have the same names, right? They're both B's, okay? But changing one does not change the other. Okay? Does that make sense? Okay. And that brings me to the concept of a local variable. So this parameter b, because b is defined inside of my for inside of the function. Let's see if I have it, some description here I can copy. Local. Nope. Really? Go up. Okay, I gotta write it. Okay, so what is a local variable? A local variable can be used, seen, or changed only in the segment in the code segment where it was defined, right? So in this particular case, B is local to pass by value, right? What does it mean that it's local to pass by value? Well, it belongs only to the pass by value function. If I make some kind of a change to B here, it's not going to affect any other B's in my program unless I do something else, which I'm not going to show you yet. Okay? So that's a B is a local variable, and the scope of B is the pass by value function. And what is a scope? Scope refers to where a variable can be used, seen, changed. Okay? So if I go in there and if I say, let me declare another variable, int c. What kind of a variable is this? It's a local variable. Local variable. It's local to what? The variable c is local to the main function. All right, this is my main function. All right. So my variable c is inside of the main somewhere. Okay? So the scope of c is only the main function. And again, what is scope? Scope refers to where the variable can be used, changed, seen. Right? So that means is if I go in there and let's say I want to do this, I'm going to do cout c equals c and L. And if I try to run the program, you already see that it's red, so it's not going to be happy about it. Right? What is it saying? Use of undeclared identifier c. I declared it. I declared it here. Right? But, so the variable c is local to the main because c was declared in the main. Right? So that means that c can only be used in the main. Variable c can only be used in the main. Okay? And that is the issue that we're encountering right here. So that's why this is bad. Okay? Got it? Okay. So that is a local variable. So the parameters, which are variables that are declared inside of the parentheses of a function, they belong to that function only. Okay? You cannot use this b, or you can try to use it, but it's not going to, if you don't have a b declared here, right? If you don't have a b declared in the main here, you will not be able to do this, right? So I take this out. Now it doesn't like this b. Why? Because I haven't declared it in the main. If I wanted to use a variable b in the main, I have to declare it in the main. This variable b here is invisible to the main. Okay? And this is something that we want. Okay? We want to hide different variables in different functions. Okay? So local variables are actually a good thing. for a reason. And the reason is this. Suppose you work on some kind of a big project, and this is going to explain to you one of the reasons why we use functions, right? You work on one part of the project, you're going to work on another part of the project. We're trying to make a car that drives itself, right? I can't write the whole thing by myself, and we're going to have to split it. Each of us is going to do some work, okay? Each of us is going to do our work in our individual functions, right? You're going to deal with like the collision, front end collision or something, right? I'm going to do with the rear end collisions, okay? What we're going to do is when you finish yours and I finish mine, we're going to combine our two functions. That's the idea behind a modular decomposition. You get a big problem, you break it down into smaller, easier to solve sub-problems. You break those down further into smaller, easier to solve sub-problems until the problems become so easy to solve that it's just the basic if, like, okay, is this number bigger than this number, or compare the distances and stuff, right? And the idea of hiding variables from each other is because you and your team do not want to affect the results of my function somehow, right? If we're both using variables b or whatever, your b is different than my b, okay? So we do not interfere with each other's variables. We do not, compromise each other's data, okay? And that's the reason why you want to have local variables. But maybe there's some kind of a variable that we have agreed on using and that it's not going to be changed, or maybe some kind of a variable that maybe we both want to be able to change between the different teams. That will be why we want to have a global variable, okay? And what is a global variable? It's something that I do not want you to use in this class, right? But you know what it is now, right? It's a variable that can be it's a variable that is declared. So global variable is declared before and outside of all the other functions. So a global variable can be accessed and changed from any other place or function inside my program. So that means that I can go in here and I can do cout d equals d, right? No problem, right? I can change it. D is equal to 100. I can go to my next function, whichever that was, C here, right? I can do d is equal to 100. I can do a cout d here, right? D equals something, which is 100, right? So I can use the global variable. Global variable can be used by all functions. So just like I can use it in this function, that's how I could use it in this function. Okay? Got it? So what is a local variable? It's a variable that's inside of a function. It's been declared for a particular function. It cannot be seen or changed outside of that function. What is a global variable? It's the kind of variable you don't get to use in this class, and it's declared before and outside all the other functions. And all the other functions get to change it. Okay? So global variables are really straightforward and easy to use. But with that ease of use comes some issues, and like I told you, you don't want to mess with different teams' data, which is why we're not going to use global variables. Okay? Any questions? Okay. And now, by the way, with this little example that I was doing here with the memory addresses, right? You have some kind of an idea that C++ actually allows you to access way down in the hardware level. Okay, so we're actually able to see what the different pieces of the memory are, right? And that's what makes C++ kind of sort of a low-level language, right? It could be a very efficient language. You can tell it to move things around memory. You can tell it to reference different places in memory and dereference them. So it's you can pretty much do almost the same things that you could with assembly language that you could in C and C++. Okay, they're actually known as kind of like mid-level languages. right? So Java is a high-level language. Python is a high-level language. If you're taking Java or Python, you can't see the memory addresses. Well, you could see some memory addresses, but not at this kind of a low-level thing. You can't go all the way down at the hardware level and just play around with things. Okay? So C++ allows you to do these things, but you know there's lots of issues that come from that. Okay? But it has its uses. So again, what do we need to know for now? What's a function? Right? Well, it's something with parentheses. What is void? Well, it's the return type of a function, which tells it void means returns nothing. What does it mean to have an int? Well, it means that the function is going to return an integer, right? I had an example with the return. Where was the return? Right here, right? So if I have a return 1 and I have a cout here and I say hello world, okay, is this going to show? No. Why?
I was gonna ask that question. Why you can't put anything below a return?
Because
Is
it's
that the end of the code, or?
because okay. So the question is, why can't you put something underneath the return? Because as soon as you hit the return, you're out of that function.
Oh.
You can have a million lines of code underneath the return, but you're out of the function. It's never going to happen, right? And actually, CLine kind of, it's so smart that it kind of guides you through this. And notice what it says: unreachable code. Why is it unreachable? Because as soon as you reach the return, you're out of that function, and you're never going to get to the cout, right? And if you don't believe it, where am I calling the return 1? Right here at some point, right? If I run the program, you're going to see some 1s in here. There's the 1s. But you don't get to see a hello world. Right? Why is that? Because it's unreachable code. Right? This will never, the below will never show because the function will exit as soon as it reaches the return 1 statement. Okay?
And then another question.
What's up?
How come my code under the return turns everything into comments, whereas yours just turns everything into brackets and into comments? Like mine are in brackets too. It just turns all the other definitions and everything into comments.
I don't know. I gotta look at it.
Okay.
I have to look at it. Okay. So these are just some of the basic things. Local variable, global variable, scope. What is an argument? Argument is the value that we pass into the function. If the argument happens to be a variable, you're not going to change the value of that variable because, for now, I'll show you later how you could. Okay, because the argument is usually defined inside of the function, so you can only change it inside of the function. What was the main? The main was the function where your program starts. Okay, if you don't have a main function, program can't run. You can compile it, you can create an object file or whatever, but you cannot make a final executable file, right? And in fact, if you look at CLine, CLine automatically makes a file called main.cpp. And the idea behind this is that you're going to have, this is going to be your runner file. And then in addition to this file, there's going to be maybe many other files out there. They're all going to be, some of them are going to be CPP files. There's other ones that could be .h header files. But all the other files are going to be called from the main. The main is going to pull all the other files, put them together, and run them as a final program. Which is why, if you try to make, if you have a CLine project, and you create another file, call it whatever you want, .cpp, and then inside that file you have a main, CLine is not going to like that. It's either going to give you an error, or it's not going to run that other file. Okay. In fact, the way you tell in CLine what to run is in the CMake list file, right? It tells it run this main CPP. If you have multiple files you want to run, you would put them in there. But if you have multiple files that have a main, it's not going to work. Okay, so you can only have one main per project because that's where the whole thing is going to start running. Okay, all right. So different functions, local, global, passed by value. Do I want to tell you anything else? Yeah. So let me tell you now why it's important for you to have your prototypes. So remember, the prototypes are basically declaring what the functions is going to be called, if it's going to return a value or not return a value, if it's going to have parameters, maybe one or more parameters. And by the way, the return type, right? The return type can be an int, could be a char, could be a double, could be a float, could be a string. So you can return whatever data type you want from a function, right? It doesn't have to be an integer just, right? I can go and change this thing to a double. Right? I can change it to char, I can change it to string, I can change it to float, right? I can change it to bool, right? I can have the function return either true or false. Okay? So, going back to the int thing. Alright. So the next thing is why you want to have the prototypes here and then the definitions after. Well, actually, you don't really. Okay, what you could do is you could have your function definitions. I'm going to throw it in there. Okay, so here's what I have. I created two more functions. So if I try to have my definitions before the main, just to save some work, because I don't want to have a prototype and then the definition that after the main, I want to have just a definition on top of the main. It would work. Most of the times, okay? Except the order in which these functions are defined is going to matter. So, for example, in here I have a function b, right? And function b calls function a. What is function a? Function a is underneath it. Notice how it's highlighting this thing here in red. That means that, C line doesn't indicate there's an issue. What is it telling you? Use of undeclared identifier function a. Well, I have declared it, but it's after. And the program works top to bottom, right? So as soon as it gets to this line, it still doesn't know anything about these lines of code here. Which is why what we're going to do is we're always going to put our prototypes. Let me move this a little. So what I'm going to do is I'm going to grab these two functions, cut them, put them after my main, right? The purpose of this exercise is to show you how the order of things matters. Here, still it doesn't like it. So you don't really need a prototype. You can just do the definition, but then you would have to worry about, okay, wait, which one's defined first and which one's second. To avoid these kind of issues and not even have to worry about them, what I'm going to do is I'm going to create my function b prototype, collapse the main. Function b, and function b was what? B is a void. Let me get the a2. Alright, void, semicolon. Okay, what don't you like? Okay, there you go. So now that we have the prototypes, the program knows there's going to be something function b, there's going to be something function a. I'll go look for them. Okay. And when you call the functions after my main, you have your function b, you have your function a after it, but CLion is no longer unhappy, right? We don't have any issues with this. Does that make sense? Why is that? Because it knows from the prototypes that there is a function a that exists. It knows where to find it, okay? And that's why you got to have prototypes. Every one of you programs prototypes on top before the main, then your main, then definitions underneath the main. Okay? Questions? We're good? So let's, and by the way, this is an example of functions calling other functions. Functions calling other functions, right? You have one function, and then from it, you're calling another function. Okay? So if I wanted to see this here, I can just go into my main. Alright, so I'm going to go in there. Functions calling other functions. And by the way, that's kind of unnecessary to say because the main is a function, and you can see that from the main we called a whole bunch of other functions, right? So, but here I'm going to have the main, which is a function, called another function, which in turn is going to call the third function. So to get the whole thing started, I'm just going to go function B, right? As soon as I call function B here, all right, and in B I'm also using variable D, which is the global variable that I declared, right? So I'm just going to take it out from there. Okay. And in it, I call function A. So as soon as I call function A, again, this is my argument. All right, argument. As soon as I call function A, the parameter num becomes equal to the argument here. So num is equal to 123. So you're going to see that num is equal to 123 when I run the program, hopefully. And there it is, right at the bottom. Got it? All right. So, what else do I want to tell you? Functions, local, global, parameter scope, some videos, functions, returning values. We got that out of the way. Okay. I guess let me write another function here with a couple of a function that combines all of them. All right. So we had a function which is a void. We had a function that returns a value. We had a function that was void and has a parameter. So why don't I make a function that is double and has a couple of parameters, right? So in here I'm going to say double sum, and in there I'm going to have a double n1 and double n2. Okay, that's my prototype again. And again, what is my function name? Function name is sum. Okay. My return type is double. It's going to return a double value, so function will return a double value. Then underneath it, let's say my parameters. Which ones are my parameters? N2 and N1 and N2. Excellent. All right. The parameters are the variables that we put in between the parentheses. So that's N1 and N2. And that's good enough. All right. So the function is going to return a double, where it's going to take two values. And maybe I want to say return a double value, the sum of n1 plus n2. Right there you go. You can be specific in your documenting the functions, and this is something that you should get into the habit of doing. Okay, because the functions are your interface with your program. The same way that a remote control is the interface with your TV, right? You don't really need to know how the TV works, right? In order for you to turn it on and turn the volume up, you just press the button a couple of times and then volume goes up. And if it doesn't work, maybe you got to change the batteries in the remote control, but you never want to get the screwdriver and start opening the thing and trying to, figure out if what's short-circuited or whatever. All right, that's the idea. If somebody's using your program or your code that you've written, it could be that other team, right? So you worked on your team, I worked on my team. I took like 6 months to write my code. I don't want to sit there and try to figure out how you did it. I want a good explanation for what the function is supposed to do. Oh, I know. Oh, it's called sum. It takes two values and then magically produces a sum of those two values. I don't care how it works. I just need to know that I plug in two values into it and it works. I need to know what values maybe I should plug in, like is there supposed to be an integer? Is there supposed to be a double, right, or a float? Those kind of things will help me with pressing the button on the remote control, but I don't care about the details, right? And that's called encapsulation. You're hiding the details in your program, right? You don't really care about the details so much. Okay, so the next thing is what I'm going to do is let's just define this thing. So this is my prototype. I'm going to copy it. Go after the main. Let me collapse the main. All right, take out the semicolon. curly brackets. And then in here, I'm going to say, okay, well, double total. And then total is equal to n1 plus n2. And then return total. Okay? And to call it, I'm going to go all the way at the end of the main. I'm going to say, why don't I let the user enter a couple of numbers, right? So I'm going to say, okay, double A and B, cout, enter value 1, cn, A. I'm going to do the same thing for the other one. This one is value 2, value B. Okay, and then in here I'm going to show you cout. I'm going to say A plus B equals, and I'm going to call the function from inside of a cout sum AB. That's it. Maybe an end up. Okay. Another way I could do it is, let's say I have another variable here, t. All right. So instead of doing it this way, so this is my, entering the information, I can say t is equal to sum AB, and then this whole thing changes to putting the t there. Okay. So I call the function from inside of a cout and then return, or make a variable equal to that function call, and then send in two numbers that the user enters. The function calculates the total, returns it, puts it in this variable, and then we're going to show it. So run. So I'll enter value 1, 10, value 2, 20, and 10 plus 20 is 30. It actually works. Okay. Questions? All right. So again, what did I demonstrate? Well, how your function can return something else other than an int. How you can have multiple parameters, right? So these are my two parameters. This and this are my parameters, right? And what are these codes? See if you remember. What was the name for these? Awesome. Arguments. Okay? Happy. I'm happy as a hippo. Somebody pays attention. Okay? Not you, Rigo. Oh, you whispered it. That's how she knew. Okay. All right. No, she's the only one who's taking notes, actually. Okay, so what else? That's about it. All right, so there's other fancy things we can do with functions. So you saw a function can call other functions. Later I'll show you how a function can call itself to create a loop. Just like we did with a for loop and a while loop, you can create a recursion, which is a function that calls itself over and over and over again. Okay, so I'm just going to go through the sample programs or the assignments and then just give you some ideas for what to do. Okay, so first one is you're just going to type up a couple of sample programs. They're in there. Okay, you know the drill. Type up everything. Type up the system and get them working. So to each following, so let me add a little explanation. So type up the two programs, the two sample programs, including the comments. Okay, make sure you type my comments. Okay, I didn't type them for myself. I typed them for you. And if you just glance over them and then just ignore them, you're not going to learn much. So that's why I want you to type them up. Okay, type up that stuff. The next thing. So I'll type up a couple of sample programs that deal with functions, and that's 34A. Okay, 34B. 34B is I give you a sample program, but not the whole thing.
Thank you.
See ya. Not the whole thing. I'm typing everything except the main. So this is the next baby step. First step was type up the complete sample program. Now step 2 is There's most of it, but you got to write the main. Okay, so just like I was writing the main and I did all my function calls in here, that's what you have to do. You have to create a main and you have to call the function in such a way that it produces this result right here. So 5 people, each person weighs 180.55 and it's this much total. Okay, and I have given you, so I give you the function prototype, I give you the function definition, that's the definition. I gotta switch these around. So this is the prototype, this is the definition. Sorry, I have that in there. And then you gotta write the main. Any questions? So this is going to be similar to how I did this here. Right? So I guess you could say this is my hint for P30, whatever this is, 34b. So this is P34b hint, right? Because I have a function, I'm giving it 2 values. You're gonna probably ask the user to enter 2 values. It doesn't say anything about the user entering any values, so you can just plug in the values yourself. Right? So when you're calling this thing, you can also just, instead of doing this, you can do, I guess, right here. Let me do it here underneath. Instead of A and B, I can say 30 and then 40 and then plug in the values in there. Right? So you don't have to actually ask the user to enter the values. You can just test it like that. Yeah? Okay? So this is your 34b hint. The next one is 35. Okay, 35, similar to the other one. But this time, what I do is I give you the prototype, I give you the main, and you have to write the definition. Okay, whatever goes underneath the main. Okay, and this thing asks you to do a function. So what the function is going to do, this function void random num, is going to make a random number between -10 and 10. Okay, and then in here, I show you how to make a random number between 10 to 20. So basically this code, you have to put it in the function, and then when you call the function is just going to return, well, not return, but show a random value between negative 10 to 10. Any questions? Sure? Positive? 100%? Anyone want hints?
Yeah, sure.
Okay. If I insist, right? Okay, so you gotta make a random number. All right, let's go in there. Let's say it's going to be a void random num. Right? No parameters. Okay. And this is your P35 hint. Alright, so you got a random number function. I'm going to write my definition. This is my P35 hint. Alright, what was my function name? Random number. I'm just going to copy it. Where are you? Here. Take out this. Alright. You're going to make a random number in there. If you forget, and not that you have to remember how to, use all this stuff. Let's do it. Let's do some of this stuff in the main. So I'm going to go in my main. I'm going to do int iSeed is equal to time null here. Then I'm going to do srand iSeed, right? Then I'm going to do the rest of it in my function. So in here I'm going to do now random num, right? That's it's supposed to show me the value. In here I can do int min, which is -10. I'm going to have int max, which is 10. And then I'm going to say return, or let's just call it random value. Int random value is equal to min plus rand modulus max minus min plus 1. And that's it. I pretty much gave you the answer. Okay? That's it. Questions? Sure. Okay, so that's 35 solved pretty much. Make sure you call it a couple of times. Every time you call it, it should show a different random number. Okay? So you got to do the definition, you got to do the main, and actually I give you the main and the prototype. Okay, 36. Now what we're going to do is we're going to write the definition of a function that returns a float that has two float parameters. The function returns the larger if of its two numbers. Okay, so I give you the prototype, I give you the main, and show you how to call the thing, and you have to write the definition. So let me give you a hint on this too. So P36 hint. Okay, so the function name is larger. I'm just going to copy that thing. I'm not going to use larger actually. I'll call it, instead of larger, I'm going to do something else. I'm going to do P36 hint. Tell it return positive. Okay? So it's going to return the negative value. Return neg. Okay? And it will be something like this. I'll say, well, if val A is negative, return val A. If val B is negative, return val B. Okay? And if both are negative, return val A plus val B. And if both are positive, return val A minus val B. Okay? That's plenty of examples. So I'm going to grab this whole thing here, copy it, go all the way at the bottom. Did I call it larger? No, return neg. Okay, let me collapse my main because it's a lot of stuff in it for now. So this is 36. And let's write it. So if val A is less than 0, that's if it's negative, I'm going to return val A. If, or else if val B is negative, return val B. Else if both are negative. So if val A is less than 0 and my val B is less than 0, then I'm going to return val A plus val B. And then if they're both positive, else if val A is greater than 0 and val B is greater than 0, then I'm going to return val A minus val B. And then I guess I'll just have like some kind of a default return 0. I guess if they're both zeros. Okay, so that's what you got to do. Similar to this is your P36. And how would you test this thing? Well, you're going to do a bunch of calls. Did I do a 35 hint? 35? I didn't call it 35. Yeah, so you have to do, this is your P35 hint. Okay, so P36 hint. Right, so if I have multiple ifs in this function, I have to check to see if my program can do every one of them correctly. So I have to check to see one time when val A is 0 or is less than 0, one time when val B is less than 0, one time when they're both 0, less than 0, one time when they're both positive, and then all those different ones. So and I have to call them from a cout. So it will be a cout, and this thing is going to return neg, bad name, but whatever. So this one will be -1 and 1. All right, that's one of them is positive, one is negative. All right, then I will do another one. Second one is negative. Then I'll do another one when they're both negative. Then I'll do another one when they're both positive. And then maybe I'll do another one when they're both zeros. All right? And by the way, there's some issues with my program. I'm not going to tell you what, but when you run it, you'll probably realize that it's not working. Okay? And that's because of the order of these things. Okay, so what I would do is I'll actually put this one first. The if should be first, this if. If they're both negative, put that first. If they're both positive, put that first. And then do these other two after those. Otherwise, it's not going to work, right? So you know. But that's your 36 hint. Now go to 37. 37, average. All right. Write and test the following function that returns the average of 4 parameters. The prototype for this function is this. So I don't give you, now I'm not giving you the main, I'm not giving you the definition, you just have the prototype. All right, so let me give you a hint for 37. P37 hint. Let's go on top of the main, create my function. So this time I'm going to have a function average, and I'm not going to use this many arguments, this many parameters. What I'm going to do is I'm just going to do a couple of them. Right, there you go, 2 instead of 4. Okay, that's my prototype. P37 hint. Throw that on. Now write my definition underneath the main. Take out semicolon, curly brackets. What is the average? Well, float average is equal to val A plus val B, both of them, add it and divide it by 2. And then I just return average. And that's it. And since this thing returns an average of 2 values, I might want to do this, cout the average of, I don't know, 2 and 4 is cout average 2 and 4. And del. Okay? So that's how you do that. And the next one, last one, string acorns. Okay, so apparently squirrels like to get together and party, and the party happens to be successful if they collect 40 to 60 acorns, but that is only if it's a weekend. Okay, if it's a weekday, there's no upper limit. Okay, so it should go something like this. So basically, if it's Monday through Friday, they need to have between 40 and 60 acorns, right? Otherwise, they're going to it's not going to be a successful party. If it's less than 40 or more than 60 on Monday through Friday, not a good party, right? Not a successful party. If it is a weekend, then you don't have an upper limit. So as long as they have 40 acorns or higher, it's a successful party. They could have 100, they could have 600, it's all successful. Okay? So I guess maybe I should give you an example of this too. I'm trying to think of what to come up with. So this is P38 hint. All right. Let's say you can sleep. All right. So let's do this. I'm going to make a function. I'm going to go all the way on top. All right. So I'm going to have a function which is going to return a string, and the function is going to be called sleep. I'm going to have an int time 1. Well, let's go just time, int time. And then I'm going to have a bool is weekend. Okay? Don't you like? Okay. So then I'm going to go after the main P38, last one. P38 int. Alright, this is my function. So the rules for this is basically, let me make it up. So you can sleep if it is a weekend. If it is a weekday, you can't sleep if time is greater than 9 a.m., right? And we're going to go with military time. Okay? We're going to go 0900, right? 0900. Okay? So, what I'm saying is, if it's a weekend, if weekend is weekend is equal to true. That's one way to write it. Okay? Another way to write this is to say if is weekend. Just like that. Okay? Same thing as the above, right? Same as the above. So if it is a weekend, since weekend is a boolean, which can only be either true or false, I don't need to say if this weekend is equal true. It's either going to be true or false, right? So if it is a weekend, I can return sleep. Okay, so you can sleep if it's a weekend. I allow you. And then if it is not is weekend, right? Another way to do this is to say if is weekend is not equal to true, right? That's one way to do it. Another way to say it is if is weekend, well, no, weekend is equal to false, right? That's another way to do it. And yet another way to do this is to say if not is weekend, then condition is always true. Great. How do you know? If this is the case, then what we're going to do is we're going to, if it's not a weekend, and if my time is less than 900, right? Then I'm going to say return sleep. Okay? And otherwise, I'm just going to return wake up. Okay? And you want to go in there and you want to go and check your program. Alright? So you're going to do cout sleep, and we're going to do one where let's say it doesn't matter what time it is, and then is weekend. No, this one is just true. Okay? Then we're going to do another one, which is so if it's weekend, if it is a weekend, return sleep. If it is not a weekend, so this is a false. And if my time is less than 100, this should be also sleep. And if you have another one, which is this time, let's say it's I don't know, 1300, and it's not a weekend, then it should return wake up. Okay? Questions? It's always true, huh? How about this one? Huh, weird. Okay, any questions? So those are your hints. Take them or not. And you know the drill. If you have any questions, send me your emails. Come see me or to my office hours. if you so desire. And gotta keep up. We're already at number 38. As you can see, we're only in week 6, and there's not even halfway this semester. So gotta keep up, or you're gonna be sad soon. Okay. There's a little quiz in there, which is set to multiple attempts. So if you don't do well the first time, do it again. And yeah, that's all for today. Now you know about functions, arguments, parameters, calling, local, global variables. Right? Yeah. All right.